Consider the function f of x is x squared plus bx plus c over ax plus d, where a, b, c, and d are constants which we need to find. We're given some information. The graph of y equals f of x has roots at x equals -3 and x equals 2, a vertical asymptote when x equals 3, and passes through the point 5, 6. Find the values of a, b, c, and d and sketch the graph of y equals f of x. Well, if we know the roots are at -3 and 2, that means that the top is going to be 0 when x equals -3 and 0 when x equals 2, which tells us that what we have is x plus 3 and x minus 2. Now we know that the vertical asymptote is x equals 3, which tells us we need to have x minus 3 on the bottom, but there could also be some constant here. It goes through the point 5, 6, which means that f of x is 6 when x is 5. So 6 is going to be 5 plus 3 is 8. 5 take away 2 is 3. And 5 take away 3 is 2, so we end up with 2k on the bottom. So 6 is going to be 24 divided by 2k. That gives me 12k equals 24, and therefore k is equal to 2. So f of x is going to be x plus 3, x minus 2, over twice x minus 3. And if we expand out there, that's going to be that f of x is x squared plus x take away 6 all over 2x minus 6. And comparing with the original, that tells me that b is equal to 1, c equals -6, a is equal to 2, and d equals -6. Now, from here, and from the information we were given in the question, we can start to draw the graph. We know the roots are where x is -3 and 2. We know that x equals 3 is a vertical asymptote. We know it goes through the point 5, 6, and that's all information that we were given. Now there's some other things that we can find. So, for example, we can do a number line analysis of the signs. So they're going to change at intercepts, so -3, 2, and at asymptotes, so 3. Now if we look at this form, the factorized form, to the left of -3, all three things, x plus 3, x minus 2, and x minus 3, are negative, and therefore combining them by multiplying and dividing is going to give us a negative. When we go between -3 and 2, the x plus 3 will become positive. The other two are still negative. Between 2 and 3, the x minus 2 is also positive, so we only have one negative, the x minus 3. And then they'll all be positive over here. Now we can find the oblique asymptote by polynomial division, which I'm not going to try to avoid in this instance, and I'm actually going to do it in full in order to explain how it works. So what do we multiply 2x by to get x squared? You multiply it by 0.5x. Multiply 0.5x by both 2x and negative 6. And we're going to get x squared minus 3x. When we subtract, we get 4x. Bring down the 6. 2x to get 4x means we multiply by 2. And this will be our oblique asymptote. And then multiply the 2 by those things. And we get 4x take away 12, which gives us a remainder of 6. Now, what that means is that we could write the function as 0.5x plus 2 plus the remainder over 2x minus 6. When x tends to positive or negative infinity, this part would tend to 0, and that's why this is an asymptote. So we know that y equals 0.5x plus 2 is an oblique asymptote. So we can put that on, and that is going to go something like this. So y is 0.5x plus 2. And then we need to do our graph using the information that we have. So we know it's going to go in this part of the graph. It's going to go negative, then positive, then negative. Looking at the points we have and the asymptotes, it must come in along the asymptote like this. So it's below the axis, so it's negative. And we didn't work out the y-intercept. But if we put x equals 0, we end up with negative 6 over negative 6, which is 1. So we know it's going through here. So it's going to curve over through there, through the x-intercept here, and it must go out along here. And then to the right of x equals 3, it's always positive. So the only thing it can really do is come down, goes through 5, 6, and then goes out along the intercept here. And here is the graph drawn on Desmos.